All right, let's work through 3 practice portfolio problems here. All right, so completing the square. Now I will tell you that this will factor, but I don't want you to factor this. I want you to practice this process called completing the square. The first thing that you really need to do here is make sure that the squared term's coefficient is 1. And so notice this is already in a nice like ABC order here, like if we were going to do the quadratic formula, which we're not going to do. But the coefficient of the squared term is 1. There's my A term. The B term is -2. And the C term is -24. So the first step you really need to make sure you do is make sure that the coefficient of the squared term is 1. And it is. If it's not, then we'll talk about in a future example of what to do. So first step we really get to skip over. Second step is we're going to move the C term, the constant term, we're going to put it over on the other side with the 0. And you might think that seems counterintuitive because we needed everything to be on the same side to factor. True, but we're not necessarily factoring in this problem. So I'm going to add this 24 over to the other side. So I've got x squared minus 2x, and then I'm going to leave some space right here. Okay, where that minus 24 was. I'm going to leave some space. And then equals, now I've got positive 24 on the right side. All right, now the next 3 little steps are going to all work in unison with each other. And so I'm going to write out what these little steps are, and you're going to question, like, why are we doing these 3 weird steps? This seems so weird, but it's how you complete the square. So the first thing we're going to do is we're going to take half the B term. Now the B term currently is -2. So half of it would be -1. So we're going to take half the B term, -1, go grab a different color here, and square it. Okay, so -1 squared is +1. Okay, then what? And, no, let me grab a different color so you know that these are the 3 distinct steps here. And then add that result, that +1 that we just said earlier, add that result to both sides of the equation. So we're going to add 1 and add 1 to both sides. And you might go, well, if I add 1 to this side, why do I got to add 1 to that side? Well, I have to maintain algebraic equality, so I got to add 1 to both. Now, what is really true about the left side is technically this is a perfect square. It's not a perfect square number per se, but it's a perfect square trinomial, which means we're going to factor this, but we're not going to factor it like the way we've normally been factoring because there's some patterns that happen to emerge. So you can automatically put a quantity here and square that quantity and go ahead and put an x out in front of it, but we need to figure out what number is either going to be added or subtracted to this x inside this quantity that is being squared. Now, to figure out that number, we get to use part of this 3-step process over here. It's really whatever the half b term was before we squared it and added it to both sides. So what was my half b term? That's -1. So I'm going to put -1 after this x. So this is the quantity, x minus 1 squared. And this is equal to, and we can do the math over here, 24 plus 1 is 25. So if you were to FOIL or double distribute this, you would end back up at x squared minus 2x plus 1. So the reason why we would call this a perfect square trinomial is because if we squared x minus 1, then this would be the result. It's a perfect square. So now the next step, we're trying to solve for x here, so we would want to square root both sides. And the square and the square root are going to knock each other out. And you might go, but there's junk in this trunk. That's true, but it's all in the trunk. So the squaring is outside the trunk. The square rooting is outside the trunk. So this will just be x minus 1. And then over here we got the square root of 25, which is 5, but also -5. So this is really plus or minus 5. Whenever we square root a number, technically you have to consider the positive and the negative root of it. Right? This is kind of like the part in the quadratic formula where it's -b plus or minus the square root of b squared minus 4ac. So this part is like the square root part of the quadratic formula. It literally is that part. The last little thing we got to do here is just add 1 over to the other side, and we get that x equals, and at first I'm going to write it like this, 1 plus or minus 5. But I don't want you to write your answer as that, because you can do this math. So what I want you to do is to take 1 plus 5 and do the math, which is 6, or the answer is going to be 1 minus 5. Do the math, negative 4. And so there are your two answers to this problem. X is either 6 or it's negative 4. Now again, we could have factored this to get to these, but you really need to practice this process of completing the square. Problem 2. So this is going to start off the same way. We have a 1 in front of our squared term, so we don't have to divide anything out, but my last example, we will. All right, so first step we get to skip over. Second step, let's take that negative 9 and let's put it back over with the 0. So let's add the 9 over. So we got x squared plus 3x, then I'm going to leave some space right here, equals now positive 9. So here's that little 3-step process again. We're going to take half of the b term. Ooh, but half of 3, that's a fraction. Ooh, blasphemy. Could we call it 1.5? You could, but we're going to practice with the fractions here. All right, so work with me. Half of 3 is 3 halves. So again, if I kind of make my little notes over here, half the b term, well, that would be 3 halves. And then I need to square it. So 3 halves squared, I get to square both the numerator and denominator, so that's 9/4. And then add that 9/4, to both sides. So I'm going to add 9/4 here, and I'm going to add 9/4 there. So again, you're going, ooh, not liking that fraction, but just work with it, please. Work with it. All right, next little move here. This is where we could go ahead and square some number, some polynomial term here, in this case a binomial. And what went after the x was the half b term, which was positive 3 halves. So we're going to put plus 3 halves here. Equals, oh boy, 9 plus 9/4. This is getting fun. Well, let's see. First, let's convert 9 into fourths. So 9 is 36/4 plus 9 more fourths would mean that altogether we have, 45/4. Awesome. And from this point, we now get to square root both sides. The square and the square root over here perfectly cancel out, and we get x plus 3 halves equals plus or minus the square root of 45/4. Now, we're going to clean this up because we are allowed to individually square root the numerator and denominator, which means that square root of 4 in the bottom is just going to be a good old 2, but that 45 can simplify. That's the square root of 9 and the square root of 5, which turns into 3 root 5. Okay, what next? Now we're going to subtract this 3 halves over to the 3 root 5 over 2. So now in the end, we've got, let's get a different color here, x equals, and I'm going to put the negative 3 halves first. So negative 3 halves plus or minus 3 root 5 over 2. And you're going to go, man, that is really an ugly answer. I don't like that. I'm sorry. We're just going to go with that. Now, this almost looks like the quadratic formula type of answer, right? And so I would say you could just leave your answer as this. But if you really wanted to make it look like the quadratic formula, I mean, notice that these two fractions both have common denominators of 2. So technically, we could combine them. This could combine, if you so desire to, negative 3 plus or minus 3 root 5 all over 2. And so you could call that your x answer instead. So either one of these is completely fine. I would honestly just stop right here. Okay? So we can't really do anything with this. This is fully fractionally square root simplified. This is as ugly as it's going to get, really. All right, third example now. Now I promised you one where there's not just a 1 in front of the squared term. So first thing we're going to have to do is divide every term, technically including the 0, by 6. So now this is 1x squared plus, oh my god, 7/6 x? Oh, sorry, a little nauseous fractions. Gosh. Oh man, more fractions. Negative 5/6 minus 5/6 still equals 0. Okay. Next step. Let's move that negative 5/6 over. And then we're going to have 1x squared plus 7/6. 7/6. And then I'm going to leave some space here. Equals now positive 5/6. All right, let's move this up, get some more space going here. Next step was to take half the b term. So I'm going to write this out off here to the side. Half the b term. Well, the b term, oh, gosh, that's 7/6. Sorry, just, oh, it's so awful. 7/6. We need to take half of it. Now, instead of dividing it by 2, let's multiply it by half because it's already a fraction. So dividing by 2 and multiplying by half does the same thing. So half of the b term, 7/6, is 7/12. Okay, so there's half the b term, and then we need to square it. Okay, so 7/12 squared, we can square the numerator and denominator. That's 49 1/44. Oh my god, this is even a bigger fraction. Oh, it's okay, guys. Then we're going to add that crazy, oh god, it's a fraction. Add that to both sides. Both, come on, give me t. There we go. Add to both sides. So we're going to add 49 1/44 to both sides. All right. Next, quantity squared, x goes in front. This is the way this always is going to work out. But what goes after that x? It was whatever the half b term was, which I kind of left over here, is 7/12. So x plus 7/12, quantity squared. Again, if you FOILed or double distributed this, you would get this lovely thing up here. Equals, oh my god, we're going to have to combine that. Oh boy. Okay, so 5/6. Geez, oh Pete. We need sixths to be 1/44. So, oh my gosh, I don't even know. Let me go grab my calculator. Where's my calculator? Calculator, there we go. How many times does 6 go into 1/44? 24 times. So if 6 gets multiplied by 24 to get to 1/44, then I also have to take 5 times 24. So 120 1/44 is the same thing as 5/6. And I'm going to add 49 1/44 to that. So 120 plus 49 makes 169 1/44 altogether. Gross. Next step, square root both sides. So we got x plus 7/12 on the left equals plus or minus square root of 169 over 1/44. Now, remember, with the square root of a fraction, you may split up the square root to the numerator and the denominator separately. And hopefully some bells are ringing off in your head. These are both perfect squares. Both of them. Square root of 1/44 is 12, and the square root of 169 is 13. We completely don't have to deal with square roots anymore magically. Not magically, mathematically. So now the last little step here, before we do some simplification, we need to subtract this 7/12 over to this plus or minus 13/12. So now let's get a tad bit more space. So in the end, this is x equals, and I'm going to write the negative 7/12 part first, do the plus or minus second, plus or minus 13/12. Now notice that both fractions are 12ths. So this is really nothing more than negative 7 plus or minus 13 twelfths as a single fraction, which means we can take that negative 7 and add and subtract 13 to it. So this is really negative 7 plus 13 all over 12, and this is also negative 7 minus 13 all over 12. So let's see, negative 7 plus 13 is 6 twelfths, and 6 twelfths is 1/2, fully simplified. Or we're going to get negative 7 minus 13 is negative 12 twelfths, and that simplifies. What can go into both of those? 4 is the greatest common factor, so negative 5 thirds. 5 thirds. Make that look like a 5. There we go. And there's our two answers, positive 1/2 or negative 5 thirds. So what looked like might be a nasty kind of square root type problem actually ended up being not so bad, because our square root of our numerator and denominator were both perfect squares. So I've tried to show you really 3 of the unique type of examples you'll see while completing the square. So good luck with the rest of your problems. And watch out for those fractions. They're very mean.